So what we're going to do now is we're going to dive even deeper into this square function. And we're specifically going to call it a quadratic function and talk about its graph. So we've seen this quite a bit in the last unit when we talked about that base function of x squared, which had that U kind of shape. And then we moved it left, right, up, down, reflected it, all of those kind of things. In general, when we have a function of the form where it's some number times x squared, a number times x plus a constant, this is called a quadratic function. And its graph is called a parabola. So we're going to focus on two main forms for it. The first one is exactly what you see here, where it's ax squared plus bx plus c. This is a useful form, but it's more useful for being able to find x-intercepts. What we really want to do is put it in what's known as standard form, because that's going to be more helpful for graphing. So the value of a is still the same. You're going to take that out of your x squared terms. But what it does by putting it in this particular form is it allows us to see the transformations. So remember that value that's attached to x is going to be a horizontal shift, and then the value k at the end is going to be a vertical shift. So immediately what this does is when I go to graph it, I would move it h in the x direction, and then I would move it k in the y direction, either positive or negative. So your main starting point will be right here at hk. And then your parabola is going to open one of two ways. It's either going to go upwards if your x squared is positive, or if the value out front here, remember, tells you to reflect it down, so it would open downwards in the case that a is negative. So all of these things do have special meanings. This point here is called our vertex, hk. And then also, if you cut this in half, you notice it's symmetric. So the line x equals h is the axis of symmetry. Okay. So we are going to have to find that vertex, and then the value of a is going to tell us which orientation it opens in. So let's get an example. Let's go ahead and graph this. Again, we don't need any new knowledge to be able to do this. This -2 attached to, or this +2 attached to the x tells us to do the opposite. Remember, this means to shift it left 2. And this -1 tells us we move it down 1. So instead of having our sharp point be at 0, 0, instead it would go through -2, -1. And so our vertex is exactly that. It's the opposite for x, so it's -2. And it's exactly the value we have on the outside, which is -1. So our vertex is just that. The value of a in this case, there is a +1 out front. So it's a positive number, which tells us the graph is going to open upwards. So it has the shape of this form. So just a rough sketch of our picture. We know our parabola opens up, and we know it goes through -2, -1. This would be a decent graph of our function f of x. And then just for completeness sake, this is going to be the line that it's symmetric about. So x equaling -2 is the axis of symmetry. So this function was already put in standard form for us, but again, you could expand it out. So this is x plus 2 squared minus 1. If you were to FOIL that, that would be x squared plus 4x plus 4 minus 1. So in general form, this would be x squared plus 4x plus 3. So again, general form is not great for graphing, but it is going to be useful when we talk about finding intercepts. Okay. For this next one, what I'm going to try to do is I'm going to try to put this in standard form and then utilize that to graph. The problem is I need something very specific and I need to find the vertex, so I need to be able to know the transformations. So this is going to use a process that's called completing the square. So I will show you another way to do this, and again, you can use whichever method you want. Both of them will have you, will allow you to be able to put something in standard form from this more general one. But the method itself you are going to have to know, especially when we talk about circles at the end of this section. So the very first thing we need to do for both of these is you want to get x plus something or x minus something. So I need to group my x terms. So what I'm going to do is give myself a little bit of space. This minus 8 is just going to be shifting the y in some way. Okay. The next thing you need to do is you need to factor out the coefficient that's attached to the x. So in this case, I need to take the minus sign out of my x terms. And what that leaves us with is x squared minus 6x. Okay. What I want to do is I want to figure out what number can I fill in here so that I end up with x plus something squared or x minus something squared. Okay. And the way we're going to find that is a very specific way. You're going to take this number, minus sign included, you're going to divide it by 2 and square it. So I take negative 6, I divide it by 2, and I square it. So I'm going to keep going with this. This is x squared minus 6x, and this would be plus negative 3 squared. And what this does is it gives us x squared minus 6x plus 9. Because what happens is at this point now, I'm able to factor this as x minus 3 times x minus 3, which gives us x minus 3 squared. So by doing this very specific process of taking this number, dividing it by 2, and squaring it, you end up with something that factors very nicely. But the problem is, I have not kept this equation exactly the same. So we have to balance the equation as well. So think of right here, it's a little bit easier to see what I've actually done. If off to the side, I go ahead and distribute this, that would be negative x squared plus 6x minus 9 and then minus 8. This is not the parabola I started with. I've magically gone and put this minus 9 here. Okay? So I have to balance my equation and make it so that this minus 9 doesn't exist. And the way I do that is I add a 9. So I do the opposite thing, because these two would then cancel, and this would exactly equal the negative x squared plus 6x minus 8 that we started with. Okay. So every time I go through this process of completing the square, I have to figure out the number that I need to add, but then I need to do the opposite at the end of the equation to balance. So really out here, I need to subtract 9 so that these, or I need to add 9 so that these two things would cancel, and I haven't changed my equation. So really every step where I've gone and added this thing, I need to add a 9 to make it a true statement. Because then from here, then we can go ahead and condense the negative 8 plus 9, and we end up with this expression. And again, I can check myself. I can check that I've gone and done this correctly. So negative 8 plus 9 is positive 1. If I were to actually distribute this whole thing out, I should get the parabola that I started with. So when we go ahead and FOIL these, this would give us negative times x squared minus 6x plus 9 plus 1, which is negative x squared plus 6x minus 9 plus 1. And in condensing, indeed, that gives us the exact same parabola we started with, okay? So this process of completing the square is quite difficult and quite cumbersome. I know a lot of students really do not like it. So we do have another way that we can go about it. And I will show you that after we learn, or after we finish this problem. Either way is going to work, and I'm going to do an example that does it both ways so you can kind of pick and choose which method you want. But from here, now that I have this thing in standard form, I can get a pretty good graph of what's going on. Our vertex is going to be at 3, 1. So remember, opposite for x, and then exactly what you see for y. And then because our value of a is negative, because it's a negative out front here, this tells us the parabola opens down. So once we plot our vertex at 3, 1, which is right here, we know the parabola opens downwards. Okay, you can pick more points along here, but this is decent enough for what we need right now. Now, the second way to find the vertex is probably going to be the method that you gravitate towards. So when you're given a quadratic function in general form, we can do two things to find the vertex. We can go ahead and complete the square and put it in standard form to get the vertex hk. Or instead, there's really a formula. So our next section is about the quadratic equation. If you remember that, it's negative b plus or minus the square root of b squared minus 4ac all over 2a. So when I go to find the x-coordinate of the vertex, it's really that quadratic formula, ignoring the plus or minus square root part. So my x-coordinate can be found just using negative b over 2a. When we want to find the y-coordinate, it is a point on this line, or on this parabola. So whatever you find for the x-coordinate, just plug it back in, and that's your y-coordinate. So if I find x is negative 2, plug it in, gives you your y. So I'm going to do one example of this so we can see another example of completing the square. We're going to find the vertex, and we need to write this thing in standard form. So the first method that I'm going to do is by completing the square. Just so we can see another example of this. And then the second way I'm going to do that is by using the formula. Okay. So to put this in standard form, I've got to group my x terms. So I'm going to give myself a little bit of room and put those together. I then need to factor out the coefficient of x squared. So we've got to take a 2 out, and that leaves us with x squared minus 8x, and then plus 22. And then I need to figure out what number I need to add here. So I take this middle term, divide it by 2, and square it. And I've got a balance, but first let's see what number we actually added in here. So this would be negative 4 squared, which really means we need to add 16 inside of here. Okay. But again, I can't just add 16 on the inside. It changes it. I've got to figure out, what do I do to balance it? So at this stage, if we distributed this 2, this would be 2x squared minus 16x plus 32 minus 22. So what I've really done is I've added 32 to my equation arbitrarily. So the way I counterbalance it is I subtract 32 to make this disappear and this disappear, and we still have exactly the same expression we started with. So really, at every step along the way, to balance, I need to subtract 32 where I've added this quantity. Okay. And again, you can check yourself, expand everything out. Do you land with exactly what you started with? But really what I've done, when you distribute this 2 back, we've added 32. We subtract 32 to make those cancel. But what we've done now is we've made this a perfect square. So this would factor nicely as x minus 4, x minus 4, and then this would be minus 10. So this simplifies to 2 times x minus 4 squared minus 10. So we've put this thing in standard form. I now immediately know my vertex is for negative 10. So opposite value for x, and then exactly what we see for the y value. All right. So this is one way we can do it, but now let's do this a second way using the formula. The advantage of this one is I have it in standard form already, but we can still do the same from here. So what I need to do is I need to figure out my values of a, b, and I'm going to do c for good measure. So we just pick them off in order from x squared down to the constant. So our value of a is 2, our value of b is negative 16, and our value of c is positive 22. So when we go to find the x-coordinate of the vertex, that's our value h, it's negative b over 2a. So plugging in our pieces, this is negative 16 over 2 times 2, which is positive 16 over 4. And we get the x-coordinate of the vertex is 4. Exactly what we got from completing the square. Okay. And now that we have the x-coordinate to find the y-coordinate of the vertex, we just plug it in. So our value of k is we plug 4 into the function because it's a point on the parabola. So this would be 2 times 4 squared minus 16 times 4 plus 22. So that's 2 times 16 minus 64 plus 22, which is 32 minus 64 plus 22. And then if you do 32 minus 64, it's negative 32 plus 22. And then last but not least, adding those together gives us negative 10. So our vertex we found in exactly the same way. It is for negative 10. Okay. The problem is this does ask me to put it in standard form, but because I know my value of the vertex and I know my value of a, standard form is y equals a times x minus h squared plus k. The value of a is 2. The value of h we found to be 4. And then our value of k is negative 10. So you end up with exactly the same thing either way you do this. Okay. So again, you can do whichever method you'd prefer. I'm not picky with it, but you are going to have to know this completing the square process because it's going to pop up when we deal with circles. So it seems a little silly that circles are in this section because they are a completely different shape, but they fit along the lines of quadratic functions because a circle involves variables squared. That's why they fit together. So I first want to go through what a formal definition for a circle is because we know what they look like. You see them every day in a lot of aspects of just what you see on the road, what you see on in just everything, your doorknobs, all of that. Circles appear a ton. The way we formally define it in math is we have some fixed point, which is hk, that's called the center of our circle, and then we fix a radius r. So that's some distance. So the way the equation for the circle comes up is we find all of the points x, y that are a fixed distance r from this center. So just in terms of the picture, here is my center, which is what we call HK, kind of like our vertex. And then we fix a distance r. Okay. Our circle is going to collect all the points that are this fixed distance r. So if you were to swing this radius around, it in turn creates this circle. Okay. And no matter where you calculate the distance from the center to the edge is this value of r. So all of these are the xy points on the circle. The equation from a circle really just comes from the distance formula. Remember, your distance squared is your difference in x's, x1 minus x2 squared, your difference in y's squared, and really we're used to this with a square root. So in our case, we fix the x and y, we subtract the coordinates of the center, and if you square both sides, that would mean you get your radius squared here. So this is our formula that we're going to use to figure out what the equation of a circle is or how to graph it. So our center is HK and our radius is r. So let's try a couple of examples. Let's find the equation of the circle with radius 3, given its center of -1, 2. And it is really just a plug and chug into our formula. In this case, both the x and y, we subtract the coordinate from the center. So here we take x and we subtract the x coordinate of the center. And then from y, we subtract the y coordinate of the center. And that equals our radius squared, which is 3. So simplifying this, the equation of our circle is x plus 1 squared plus y minus 2 squared, and that equals 9. Okay, and if you want to graph this, we definitely can. So let's go ahead and plot all of our important points. So I'm going to go 1, 2, 3, 4, 5. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3. So our center of our circle is at -1, +2. And then our radius is 3, so I'm going to go upright, left, down a distance of 3. So 1, 2, 3. I get another point that would be right here. Then I go 1, 2, 3. Another point on our circle is right here. 1, 2, 3. Third point down here. And then finally we'll go left, 1, 2, 3, to get this other point right here. Okay. Now clearly, because I can't draw things great by hand, it's going to be a bit of a wonky circle, but that's okay. This would be the graph of the circle. All right, and our very last problem, what we're going to do now is we're going to have to find the radius and center, so it's not given to us. And in this case, it is completely expanded, so it's not in that nice form where I can immediately pick off the center and radius. So this is where the idea of completing the square is going to come into play, but it's much nicer for circles than it is for parabolas. So here, because we have x and y terms, we do have to complete the square twice. So the very first thing we want to do is we want to get the x stuff together. We want to get the y stuff together. And then I'm going to move this constant to the other side. Okay. So grouping our x's, we have x squared minus 4x. Giving ourselves a little bit of room, we've got y squared minus 16y. And then on the other side, we have negative 32. So in both of these, I need to add some number that makes it a perfect square. And then I need to balance because I can't just randomly add something. The way we find the constant to add is the same way. I take the middle term, divide it by 2, and square it. And same thing over here. I take the middle term, divide it by 2, square it. So that gives us x squared minus 4x, and this would be plus negative 2 squared. And then y squared minus 16y, and that will be plus negative 8 squared. Okay. And one last step before we can go ahead and actually balance this. So this would be plus 4 on the inside. And then here, this would be plus 64. Okay. And so the beauty about this one is I don't have any numbers that are out front. Really, I can drop these parentheses. They do absolutely nothing. So on the left-hand side of the equation, I've added 4. I've got to do exactly the same thing to the right-hand side. On the left-hand side, I've added 64. I've got to do exactly the same thing on the right-hand side. So we add 64 to both sides. So much easier to balance the equation out, because what do you do to one side, you do to the other side. Right. So now here we go ahead and factor, and this factors nicely as x minus 2 squared. This one factors nicely as y minus 8 times y minus 8, so y minus 8 squared. And if you do negative 32 plus 4 plus 64, it ends up equaling 36. So we now have it in our standard form that I can immediately say the center is going to be at 2, 8. And then our radius, remember, is the radius squared here. So we take the square root of it. It's a square root of 36, which is 6. So we'll come back and we'll discuss circles again later on in the semester, but for now, this is about as deep as we're going to get into it.